welcome back to the channel. So we've got another look at the discriminant here and having a look at a few bigger problems and how we can use the discriminant to solve them. But before we do that, we'll just look at calculating the discriminant for two different quadratics over here. So a quick recap is this. Remember we said that the discriminant, when it is bigger than 0 or greater than 0, it means the equation is going to have two real roots, or there'll be two intersections with the x-axis. When the discriminant is equal to 0, it means there is only one solution, and the graph is just going to touch the x-axis at one point. And when the discriminant is less than 0, there are no real roots, so the graph is not crossing the x-axis there at all. So let's check out the first one. Over here we'll have a is equal to 1, b is also equal to 1, and c is equal to 2. So if we put that into the discriminant, we'll have b squared, which is 1 squared, minus 4 lots of a, which is 1, times by c, which is 2. So this is going to come out as 1, take away 8. And so the discriminant here is minus 7. So what does this mean? Well, it means that this here is going to have no real roots or no solutions. So let's put that no solutions. And remember why? Because obviously this part, if it's negative, you're not going to be able to square root it, and so you can't get any real solutions. Now let's check out the next one. So a would equal 3 this time, b would equal minus 2, and c would equal minus 7. Let's plug that into the discriminant. We'll have minus 2 squared, take away 4 lots of 3 times by minus 7. So minus 2 squared, that's 4, minus 4 times by 3 is 12, 12 times by 7, 77, 84. There we go. And actually, because you've got a minus and minus there, that's actually going to be a plus. So when you add these together, we actually get 88. So this time, b squared minus 4ac is positive. So if it's positive, it means this here is going to have two real roots, or two solutions. So there we go. Nice and simple to begin with. Now for the next one, we've got to find the range of values of k, given that this equation here has two real solutions. So when something has two real solutions, what do we know? Well, we know the discriminant must be greater than 0. So what we can start by doing is saying this. We can say b squared minus 4ac must be bigger than 0. Now we know from here that a is equal to 3, b is equal to minus 4, and c is equal to k. And so what we can do with this is maybe put that into our little discriminant over there. So we'll have minus 4 squared, take away 4 lots of 3, times by c, which is, well, k in this case. And that's going to be bigger than 0. So then minus 4 squared, we've got 16 minus 12k. It's got to be bigger than 0, and now what we've got is just a simple inequality that we can solve. So take the 12k over, so we'll have 16 has to be bigger than 12k, and then k has got to be smaller than 16 twelfths, and then that can simplify, isn't it? Divide both of those there by 4, so we'd have, there we go, k has got to be bigger than 4/3, so that's going to be our answer for that one. And now for the last one, find the range of values of k, given that this equation has no real roots this time. So quite similar to this one here, what we'll do is start by writing the discriminant out, b squared minus 4ac, but this time, because it's got no real roots, it's got to be less than 0. And then let's start writing out what a is. So a is equal to 2, b is equal to minus 4, and c is equal to k again. So if we start to plug this all in, this time we've got minus 4 squared, take away 4 lots of a, which is 2, so 4 lots of 2, times by k is less than 0. So that there is going to give me 16 minus 8k. This time is less than 0. I'm just going to bring this over here. So we've got 16 minus 8k is less than 0. Take the 8k over. So we have 16 is less than 8k, and then finally divide by 8. So we get k is then bigger than 2. There we go. And that's that one solved as well. So a couple of simple questions there where we've just got to use the discriminant, plug some values in, and we get an inequality, and then all you're left with is just an inequality to solve. So hopefully that all makes sense, and we'll try having a look at another problem slightly more challenging than these two in the next video.